Edexcel A-Level Maths, Pure Paper 1, October 2020, question 15. The curve C has equation x squared tan y equals 9 for y between 0 and pi over 2. We need to show that dy by dx equals minus 18x over x to the 4 plus 81. So we've got our x squared tan y equals 9. This is a product of x squared and tan y, so we're going to differentiate using the product rule, which is when we've got our product uv, we have v du dx plus u dv dx. So with this example, the first thing we're going to do is differentiate the x squared, which is 2x, and that remains times by the second part, the tan y. We now need to differentiate the tan y and multiply this by x squared. Now remember, we're differentiating with respect to x, and this is tan y, so the chain rule comes into play. So the differential of tan is sec squared. So we're going to get sec squared y dy by dx. We've got to remember that dy by dx part there for the differential of tan, and we're keeping the x squared in front of it because of our product rule. And then on the right hand side, the differential of 9 equals 0. Now to simplify this, we can see that sec squared, we've got our identity for this to change it into tan. That's 1 plus tan squared. We now need to get rid of all these y's because the dy by dx that we've been shown, that we're aiming for, is all in terms of x. Well, our original equation was x squared tan y equals 9. So if we divide both sides by x squared, we know that tan y equals 9 over x squared. So let's substitute this in to our equation. So we get 2x, 9 over x squared, plus x squared times 1 plus 81 over x to the 4, dy by dx equals 0. This simplifies to 18 over x plus x squared plus 81 over x squared dy dx equals 0. Now taking away the 18 over x from both sides, dividing by the bracket, gives us that dy by dx equals minus 18 over x all over x squared plus 81 over x squared. Well, we've got fractions within a fraction here, which is a little bit messy, but if we multiply all our terms by x squared, that will get rid of that, and we'll get minus 18x all over x to the 4 plus 81 as required. For part B, we need to prove that C has a point of inflection at x equals the fourth root of 27. So we're dealing with points of inflection, we need to find the double derivative. dy by dx we've already got is minus 18x over x to the 4 plus 81. We're going to differentiate this again using our rules of differentiating fractions. So we'll end up with this here. So to get this, we've done the derivative of the numerator. So minus 18x has become minus 18 times by the original denominator, x to the 4 plus 81. Then we're taking away the original numerator times by the differential of the denominator. So that x to the 4 has become 4x cubed. This is all over the square of the original denominator. Simplifying the top, we get minus 18x to the 4 minus 1458 plus 72 x to the 4 all over the square of x to the 4 plus 81. Bringing the x to the 4's together, we get 54x to the 4 minus 1458 all over the square of x to the 4 plus 81. Now the top two numbers are both multiples of 54, so we can factor that out. So we get that d2y by dx squared equals 54 times x to the 4 minus 27 all over x to the 4 plus 81 squared. Now we need to prove that C has this point of inflection at x equals the fourth root of 27. So let's see what happens at those values. So at x equals the fourth root of 27, plugging that into our d2y by dx squared, we get 0. When x is smaller than the fourth root of 27, again plugging them in, d2y over dx squared must be less than 0. We can see this because inside our formula for d2y by dx squared, we've got that x to the power of 4. So that would become 27 when x is the fourth root of 27. So if it's smaller than that, x to the 4 will be smaller than 27, hence the whole thing will be less than 0. Other way round, when x is larger, we can see by putting that into x to the 4, we'll get a number bigger than 27, hence d2y by dx squared must be larger than 0. So our double derivative is equal to 0 at the point, it's smaller than 0 when x is below the point, larger than 0 when x is above the point, therefore it must be a point of inflection. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.